Welcome back to Soflex Math. First of all, I want to say great job. Those of you who've been working through the whole mastery course and been with me unit by unit, excellent job. You're making awesome progress. Be very proud of yourself. Today we're going to be working on subtracting mixed numbers. So we have 7 3/4 minus 2 1/5. And it's going to be very similar to what we did with the adding of mixed numbers. We're going to have to find our common denominator, and then we're going to have to subtract our wholes. So let's go ahead and start on that. So let's go ahead and see 3/4 and then the 1/5. We're going to have to find a common denominator for that. So let's go ahead and find that common denominator of 20. So 4 times 5 is 20, and 3 times 5 is 15. 5 times 4 is 20, so 1 times 4 is 4. And just don't forget the signs. Pay attention. We're going to subtract now. So 15 minus 4 is 11. Denominator stays the same. And once again, remember the sign. 7 minus 2 is 5. So our final answer here is 5 and 11/20. So notice how we subtracted the wholes, and then we subtracted our common denominator fractions. So pretty easy, pretty straightforward. Same thing as we did with the adding ones, just subtracting now. All right, we're going to look at a couple different examples in some different situations, the way they might look. So let's look at those. All right, so 6 5/6 minus 2 1/4, kind of our same way here. So let's go ahead and make our common denominators of 12. Okay, 4 times 3 is 12, so 1 times 3 is 3. 6 times 2 is 12, so 5 times 2 is 10. Go ahead and subtract, and you'll end up with 7/12. And then 6 minus 2 is 4. All right, so 4 and 7/12. Okay, and just like the adding, we can try to solve this one with improper fractions as well. So let's go ahead and rewrite our problems over here on this side. So let's do 6 and 5/6, once again minus 2 1/4. And let's go ahead and turn those into some improper fractions. So 6 times 6 is 36, plus 5 is 41. So kind of a big number there, over 6. 4 times 2 is 8, plus 1 is 9, over 4. Now, this may or may not be a good method, all right, because we still have to find our common denominator. So our common denominator is 12, just like it was before. So we still have the same common denominator. But now you might have to multiply a little bit bigger numbers. So 41 times 2 is a big number, 82. And then 4 times 3, 9 times 3 is 27. Okay? So our denominator is going to be a 12. Okay? And then we're going to have to subtract, remember. So 82 minus 27. And that answer would be 55. So let's go ahead and write that, 55. All right, and then we're going to turn it back into a mixed number. So how many 12s can go into 55? 4. So 12 times 4 is 48, plus 7 more gets you to 55. So we do have matching numbers. So once again, not always the best strategy depending on what numbers you're working with, but sometimes they work out nice and compatible and easy to work with, and it's nice just to subtract the improper fractions first. So like I said, another method, you don't have to use that one, but it's always good to see different ways of solving it and just seeing how mixed numbers and improper fractions are indeed equal. All right, 2 more different problems here. So this next one, you're going to have to do something called borrowing, just like we borrow from whole numbers. So if you couldn't take 3 from 2, you'd have to borrow. So we're going to do the same thing with some fractions. So our first step is still to find the common denominators. So we're still going to have 15s. So that part is the same. Okay, finding the numerators. That part is still the same. But what's different now? Now we have 6 take away from 5. We can't do that. All right, so this is what I mean by borrowing. So we're going to go over here to the whole number 7, cross that out, make it a 6. But instead of you can't just add 1, you don't make that a 15. You're going to add, remember how we said we could represent any fraction as 1? We just write it over itself. So 15 over 15, we just use that denominator. 15 over 15, 15 over 15 is the same as the 1 we borrowed. So from 7 to 6, it just went over here and became a 15 over 15. Because now, if you look and remember from our adding with the like denominators, we have a new fraction of 20/15ths, an improper fraction. And now I can do 20 minus 6 is 14 over 15. And then 6 minus 3 is 3. So just kind of take a moment to look how we borrowed. So we crossed out our 7, made a 6, just like we normally would. But you don't just put a 1 over here. You add what is equal to 1. Well, 15 over 15. Okay, or 7 over 7, or 8 over 8. Any number over itself equals 1. We just want to do it so we can add our numerators. If we have the same denominator, we can add the numerators. And then we do 20 minus 6 is 14. Denominator stays the same. And now 6 minus 3 equals 3. All right, so one last problem. This one we're going to have to deal with. What do we do if we only have a whole number, just like we did with adding? It's a little bit different for subtracting. All right, with adding it was pretty easy because we just do, just move the 1/7 down and say 5 plus 2 was 9. But this is subtracting, so you can't subtract 1/7 from nothing. So we're going to have to borrow again. So basically all we're going to do is we're going to rewrite our fraction of 5. And we're going to rewrite it as 4 and 7/7, because 5 is this 4 plus 7/7 equals 1. So 4, 5. It's the same way. And then we're just going to rewrite our bottom number, or mixed number, the exact same way. And now we have a nice easy problem. 7 minus 1 is 6 over 7. And 4 minus 2 is 2. So notice how our 5 turned into a 4 and 7/7. Why did I choose 7/7? I just looked at whatever this denominator was. If this denominator was a 5, I would have made this 5 over 5. If this was a 19, I would have made it 19 over 19. Because remember, any number over itself equals 1. So 4 and 7/7 is the same as 5. But I needed to be able to subtract 7 minus 1, and I needed to be able to subtract 4 from 2. So this is just another way of kind of borrowing or rewriting a number in order to do subtraction of mixed numbers or mixed numbers and wholes. So once again, our next lesson is going to be working on some word problems with fractions, with adding and subtracting, and adding and subtracting mixed numbers in word problems. So just to kind of see what those look like. So we will have a chance to practice all 4 of these types in our next lesson. So thanks for watching Soflex Math, and we'll see you then.